Okay, hello everyone, welcome to AP CSP Unit 7 Online Data Security. Today we'll be going through Introduction to Online Data Security, PIL, user data tracking, cyber attacks, data encryption techniques, secure internet protocols, and user authentication methods. So we are going to look at introducing online data security. So why should we care about this? It is because the internet is a vast network and is processing billions of gigabytes of data every month. And all words that we are speaking could be adjusted into a billion gigabytes. That's a lot. And if we don't really care about the security of the information that we are using and speaking, it will lead to some serious matter and might damage your personal life and stuff like that. But before that, we gotta know data flows and different types of information. So they could be split into numerical data. So this is like temperature of a city, categorical data like genre of a movie, personality, identifiable information. This includes data like your name, address, or any other details that could be used to be an identifying thing for you. So this is like the most important part we're going to be looking at today. So now let's dig deeper into PII. So this is personal identifiable information. This plays a really important role in identifying and personalizing services for people. But in the internet, this could lead to some security issues and privacy concerns. And we can look at different types of PII. So one of them would be direct identification. So this means that some types of PII can be immediately noticed and without needing any additional data. So for example, there's an example here. So name and your social security number, biometric data. So if we put fingerprint. And then we have indirect identification. So like other types of identical data could be like race, location, medical data, something like that. So they may not directly identify the individual, but can also find some of your information when they combine together and relate with each other. And after talking about different types of PII, we can take a look at why are they being classified and what it challenges. So one of them is IP address. So some people argue that they're they're not PII. So since they identify devices rather than people, so it's not themselves, but rather the device they identify. But others view them as like linkable PII. So they can reveal geographical locations or be tied to individuals through additional data. And for PII theft, so this is what we're going to be focusing today. So PII theft, so it's when attackers target companies and individuals to access their PII. So this is often made through data branches. So one of the examples could be when in 2017, Equifax they suffered from a breach that exposed the PII of 143 million Americans, so including social security and credit card numbers. So now we can take a look at user data tracking. So this is essentially an understanding how personal data is collected, proceeded, and utilized in digital world. So I can explain to you guys by tracking methods, real-world applications, associated skills, and how can it be related to some of the topics we're going to be introducing today. So we can start from web cookies. So they are small text files which are stored in user's browser by a website, and they record users' activity and preference. This helps them to improve functionality and provide personalized experience. And there are three types of cookies. So first we can see that there is the so types of cookies can be classified into first party, third party. So first party is like creates the website you're visiting and remembering login details or like sorting cart items. And while the third party is created by an external domain, so like advertisers. So they allow them to track users' activity across different websites. And then there are also sessional cookies, uh, pres- persistent cookies, and third-party cookies. And then we have search history. So search history is referring to the records of queries entered into the search engines like Google, Bing, or some other search engines you have in your country. They first store data to refine their service and then deliver personalized results. So they track keywords, search time, device information, and maybe even location during the search. Like some world applications could be Google or ad recommendations, trend analysis. So analysis aggregate search history and help platforms understand global or regional trends. But we gotta know that this also has risks. So storing search history can reveal sensitive information like medical concerns or financial queries. Also, searching data branches can expose personalized preference or habits. This could be dangerous if in some special cases, but you don't have to worry about it usually. Then we can take a look at browsing history. So browsing history includes the URLs or websites visited. This can also include timestamps and metadata or what you're interacting with. So like how long have you stayed on the page. Browsers like Chrome or Firefox, they store data locally, so while websites are on the third party trackers store it remotely. So some examples could be when you're experiencing behavioral advertising. So if you visit the travel websites, you might see ads for vacation packages. That's like one of the real world applications we have. Another would be content recommendations. So platforms like YouTube or Netflix, they suggest content based on your browsing or watch history. So your also TikTok is also part of it. So they will analyze what you're watching mostly, and uh, they will try to give you the videos you would prefer more compared to other videos that you would not like to watch. And at last, we have analytics. So, website owners analyze browsing patterns and then they optimize content and improve the user's engagement. Some risk associating browsing history could be when you are having unauthorized access to browsing history, and this can expose sensitive behaviors or interests. And now, geolocation. So, geolocation is like GPS, Wi-Fi signals, Bluetooth, or IP addresses. So they pinpoint a user's physical location, and devices and apps often request location permissions to offer local services. Some real world applications could be navigations, local recommendations. So those two apps both need your actual location. So they require to know where you're at specifically. And this risk is pretty obvious. So they are tracking your movement and where you're at, where have you been throughout the day, which country. This is some pretty important privacy informations at this point. And now we can take a look at cyber attacks. So cyber attacks are at- attempts to gain unauthorized access to computer systems, so they're illegal. So like networks, data, these attacks aim to disrupt services, steal sensitive information, and damage the system. So any type of attack that is trying to damage your computer network or trying to steal your personal information are cyber attacks. So let's take a look at different types of cyber attacks. So first we have phishing. So this type of social engineering attack where attackers trick users into sharing sensitive information. So like password, credit cards, information, or just phone number even. So they message you an email saying that your sync might expire and you gotta provide them some kind of information that is not supposed to be told to other people. And now let's take a look at rogue access points. So rogue access point is an unauthorized or malicious wireless access point. So connected to a network and can be set up by either attackers to um, try to break into a network or by employees creating significant cybersecurity risks. So the uh, process of rogue access points, so they work basically, we can split them into three parts. So first is installation. This is when rogue access points are either intentionally set up by attackers or unintentionally by employees who connect unauthorized devices to the network. And then is deception. So this is when attackers configure the rogue access point to the mimi a legitimate network, so they trick users into connecting to it. So then this would lead to intercept traffic, spread malware, and access internal systems. And now we can take a look at the need of encryption. So encryption is the process of covering information into coded format to protect it from unauthorized access. So this is basically setting up passwords in easy way to say it. And why do we need to encrypt data? So data privacy. So this protects us from being attacked by hackers and people like that. So this keeps us safe from losing our data and giving it to other people. And then data integrity. So this makes sure that data is not tampered with during the transmission or storage. So encryption could also be used in transforming data, also in passwords. So they're not only limited into one type of uh, use into internet transport and stuff like that. And then we have authentication. So this verifies the identity of the sender and receiver in the communication process. And at last we have the compliance. So this meets regulatory requirements like GDPR, HIPAA, or CCPA. So they mandate encryption to protect user data. So those meaning are the platforms and services that handle sensitive user data and they are required to meet regulatory standards such as GDPR. So this is referring to General Data Protection Regulations and HIPAA. This is Health Insurance Probability and Accountability Act. And CCPA is California Consumer Privacy Act. So these regulations and they are making sure that the use of encryption and other security measures are protecting the user data in both transit and at rest. And here are some examples of encryption and decryption and cracking. So here plain text would be hello world and then after we encrypt the code, so we add the text, so it would be this as you guys can see. So this is using simple Caesar cipher with a shift of 3. So this is a way of encrypting data. And then decryption is when we change the coded code and then we change it to plain text. So for example here, we change the code core drug and then this will translate into hello world. And then cracking. So cracking is just using brutal force. You just try all the possibilities and then find the right answer. And then one of the important things we gotta consider is public key encryptions. So they use two mathematical related keys, so a public key and a private key. And here we can see security internet protocols. So they are in ensuring that data is transmitted over internet and is protected from interception, tampering, and unauthorized data. They're critical for maintaining confidentiality, integrity, and authentical in online communication. In human words, so this is just making data safe when they're transmitting over internet and they're being protected while they're transferring. And then we can take a look at transport layer security, so TLS. So this is an cryptography protocol, so it's designed to secure communications over a network. So as I introduced before, so encryption, integrity, and authentication. So they are both how just these three are showing how transport layer security work. And what we gotta get to know is digital certificates. So a digital certificate is an electronic document, so and used in cryptography and proves the ownership of a public key. So some of them we gotta get to know is certificate authorities. So this is trusted organization responsible for issuing, validating, and revoking digital certifications. And we're not going to look into too deep on the functions and stuff like that because it's not really related to our AP CSP test, I would say, in my opinion. And then we can see here's the HTTP secure. HTTPS is also called Hypertext Transfer Protocol Secure. So this is an extension of HTTP that uses TLS or SSL to secure communications between web browser and the server. So they first establish a connection, and then so this is when a browser connects to a website using HTTPS, and then the browser and server establishes an encryption key using TLS, so making sure that your connection is safe. And then all data exchanged between the browser and the server is encrypted. And at last we have user authentical methods. So this is when the process is of verifying a user's identity, so before granting access to the system. So this is making sure that the person trying to access the data is safe. So this in human words, this is basically just setting up passwords. So like a password is usually recommended to have um, numbers, letters, and captions. So here's an example of a strong password. So here they used at least 12 to 16 characters long, and they have numbers, letters, and capital letters, and different kind of symbols to make sure that the password is secure enough. But some risks of passwords, so easy passwords could be guessed easily, but strong passwords could be sometimes preventing the owner instead of the hackers. And the last bit of our today's work is multi-factor authentication, MFA. So this is a security mechanism that requires users to provide two or more verification factors to access the system. So will you guys all have access the Apple ID when trying to buy stuff or to pay? So maybe it will first let you type in your ID and then password, and then after that it will send a verification to your um, another device to prove that you are the actual owner of the Apple ID, and you're the person who wants to do this action. And here, and basically on Google, so there's a password and a verification code, and online banking password and a one-time PIN sent through SMS. And some other examples which we're not going to be covering, but you guys get the basic idea. So this is it for today. Thank you for watching. We shall see you next time.